Last class, we've been working on combining functions. So that means taking two functions and putting them together, kind of gluing them together in one way or another. So the first way that we combine functions is just by adding and subtracting and multiplying and dividing, the same thing that we've been doing with numbers since we were in grade 1 or grade 2, right? But now we're adding and subtracting functions, and functions have all sorts of interesting properties, so it's much more complex. So another way that we can combine functions is with this idea of composing them. So the composition of functions is where you take a function of another function. So it's one more way of combining them. Okay. So the composition of a function is written like this. So we can compose two functions f and g in the following way. Okay, so if I have my first function, okay, I can compose it with another function, and I do that, and this is kind of funny because I actually write this backwards. It kind of goes in reverse, and you'll see why. So this is called G composed with F. So G composed of F of X, and it's a little empty circle. That's the symbol that we use. It's an empty circle, pretty small circle. And I try to make it as circular as possible so it's not confused with a 0 or an O. So I try to make it kind of a small circle, and it's empty. We don't fill it in. So G of F of X is equal to G of F of X. Okay? So that's the composition of functions. And we say that this is G composed with F. Okay? So the reason we write it backwards, you might wonder why we write it backwards, is because the first function that we really think about is the one on the inside. Right? Our order of operations tells us to worry about what's inside the brackets first. And what's inside the brackets is f of x. So we kind of think of our function f as the first function that we worry about, and then we're plugging that function into the function g. Okay, so let's do a quick example. So e.g., let's try. I'll just make up two functions. Let's say that this one is here's my f of x. Let's make it a simple function like a linear function. Let's call it 2x plus 1. Okay, so there's my first function, f of x. My next function will be g of x, and I'm going to call that, let's do a quadratic. Let's have some fun. Let's call it a quadratic. So we'll call this 2x squared minus 3. How about that? Okay, 2x squared minus 3. Okay, so I'm going to give us a couple of questions just to warm up. I want us to calculate. Well, let's just warm up. Let's calculate f of 2. Okay, that's going to be the first thing that we calculate. Then I want us to calculate f of g of x, or maybe I should actually write it in the way that we're trying to learn. So f composed with g of x, and then I want us to find g composed with f of x. So we'll go in both directions. So we'll see if we can get the same number depending on whether or not we compose the first function with the second or the second function with the first. Okay? So let's start off with f of 2. So f of 2, that's equal to, well, let's just remember how functions work. Okay, 2 is the number that we're putting into the function. So I'm going to take this x and I'm going to replace it with a 2. So this is going to be 2 times 2 plus 1. So that's going to be 2 times 2 plus 1. Maybe this wasn't a very good example. I try to use different numbers as often as I can. That way we don't get confused, because now you might be thinking, well, is that 2 this 2? Well, no, this 2. I'll color code it. How about, let's say that let's make that number. Oops, didn't do that. So f of purple 2 is 2 times purple 2 plus 1. So that's where that 2 is from. Okay, and that's of course equal to 5. That's equal to 5. Okay. So that should be kind of review type stuff. Let's try the next one. Let's do so that was the first one. Let's do the next one, which is f composed with g of x. So f composed with g of x, that is equal to, well, f of g of x. Okay, so now instead of plugging in 2, like just like a normal number, we are plugging in g of x inside f of x. So we're instead of plugging a number into our function, we're throwing another function into our function. Okay, so let's see what that looks like. So what I'm going to do is I'm gonna do some more color coding, and I'm hoping that the color coding helps. So I'm going to make g of x purple, just like I did with the other one. So let's call it purple. There we go. Okay, so I'll kind of go back and forth with my colors. You're welcome to follow along with colors if you want, but certainly not necessary. Okay, so f of x is 2x plus 1. Okay, so I'm going to have 2 times, in this case, g of x, 2 times g of x plus 1. Okay, because if you remember, f of x is equal to 2 times x plus 1, right? So now my x is g of x. So it's going to take a minute for your brain to sort of adjust to this idea, but the idea is we're just plugging in one function into another function. So instead of a value, we're plugging in a function. Okay? So if I have 2 times g of x, well, let's recall what g of x is. G of x is over here, right? There's my g of x. G of x is 2x squared minus 3. So maybe I'll write that again over here. So g of x is equal to 2x squared minus 3. So I'm going to replace my g of x with 2x squared minus 3. So this is equal to 2 times 2x squared minus 3 plus 1. I'm almost done. I've done all the sort of the composing of the functions. The rest is just to simplify it with algebra. We want to kind of clean that up, make it look nice and neat. So I'm gonna end the color coding now. So really all that remains to do is to distribute this 2 throughout the brackets, and then I might have to clean up the constants. So let's see what that looks like. So 2 times 2 is 4, so I've got 4x squared, and then 2 times negative 3 is negative 6, and then I've got plus 1. And now, like I said before, we'll clean up those constants. We get 4x squared minus 5. Okay? So that's what f composed with g of x looks like. Now let's take a look and see what happens if we do it the other way around. Like if we plug in f into g this time, because this time we plugged g into f. Let's see what happens if we plug f into g. Okay, so we just finished doing this one. Let's do this one now. Okay, so we'll do one more. I guess I need another page. There we go. Okay, so we want, I'm gonna copy this just so I have it on hand. I'm gonna do copy. There we go. I'll just paste it right here just so I have it as a reference, because I don't have a very good memory. Okay, let's try this one. So we are looking for G composed with f of x. Well, that's going to be G of f of x. Okay. And well, I may as well do some color coding again. So oops. So let's call f of x. Let's make that color. How about oops? Let's make it how about orange? And then I'll make f of x orange. Color is orange. Okay. And then this x is now going to be our f of x. I'm going to make that orange as well, so you can kind of see exactly what we're doing here. So that should be the color orange. Okay. So g of x, or sorry, g of f of x is going to be, well, 2 times f of x. Let me get my orange out. 2 times f of x squared minus 3, right? So really what I'm doing is I'm taking what my input is. There's my input. I'm multiplying that by 2 and squaring it, right? So let's now replace f of x with what f of x actually is. This is equal to 2 times, well, f of x, we've already said, is 2x plus 1. I'm going to square it and then subtract 3. See what we get. Well, doing our order of operations, well, there's really nothing we can do inside the brackets, right? But the next up is exponents, right? So let's worry about those exponents. So this is going to be equal to 2 times 2x plus 1 times 2x plus 1 minus 3. That's what the exponents do for us. So let's multiply out those exponents. So I've got 2x times 2x, which is 4x squared. Then I've got 2x times 1, which is 2x. Then again, 1 times 2x. So that gives me plus 4x. And finally, I've got 1 times 1, which is 1. Okay. Don't forget about the 2 out front here, right? This 2 is still important because now we are going to multiply all throughout those brackets using the distributive property. So this is going to be 8x squared plus 8x plus 2, all minus 3. And then finally, we'll clean up that constant. So 2 minus 3 is negative 1. So 8x squared plus 8x minus 1. There you have it. Pretty different result, right? Pretty different result. So we'll notice that f composed with g of x is not the same thing as g composed with f of x. Order matters. Okay, order really matters with this thing. So when you're composing functions, it matters which you do first. Okay. So another way of saying that order matters, by the way, is saying that the composition of functions is non-commutative. Okay? So it's non-commutative, which means, well, commutative means that, well, an example of a commutative operation would be multiplication, because A times B is equal to B times A. That's commutative. This means that that's commutative. Okay? So some operations we say are commutative. Some operations are non-commutative, which means that the order matters. It matters which one you do first and which one you do second. Okay? Another example of a non-commutative action would be subtraction, right? A minus B is not equal to B minus A, right? It matters which one you do first, right? Like 6 minus 7 is negative 1. 7 minus 6 is positive 1, right? So yeah, we are familiar with some non-commutative actions. This is another non-commutative action. So, so there's one example for you. I'm gonna do one more example before I end the video, and then we'll have some time to chat and work. This time I want us to try to combine some functions using composition, but we only have the graph. So let's think about how we could use a graph and to do this in kind of a visual way. Okay. So we're gonna try three things. I want us to find G composed with F at 0, then F composed with G at 0, and then G composed with itself at 3. Okay. So this time, not only are we plugging in a function into another function, but we're also plugging in a value into the first function. So let's think about what this means. So let's first start off by saying, well, G composed with F of 0, or I should actually write it out properly, pardon me. So G composed with F at 0 is equal to, well, G of F of 0. Well, let's find out what F of 0 is. So what's F of 0? So if you haven't noticed already, this is the function of F. This is the function of G. So let's see what happens when F is equal to 0. So remember, here's my x-axis. So I'm going to find 0 on the x-axis, which is right here. And let's see where the function is at that point. It's at -2. So F of 0 is equal to -2. So that means I'm looking for G at -2. Okay, so G at -2. Now I go to the next function. Now I go over to G. Okay, so now I'm looking for -2. So on my x-axis, I'm looking for -2. So, well, here's 0, -1, -2, right there. So it looks like this is a linear function. It's a straight line. And it looks like between -4 and 0, I go up 1. So if I'm at -2, that's about halfway. Well, it's not about halfway. It's exactly halfway. So this looks like the value of 1/2. So G at -2, G at -2, at negative, I guess I can just write, is equal to 1/2. Okay. So it's almost, I'd say that it's a little more straightforward when you're looking at the graphs, because you're just kind of pointing at numbers and you're taking one number to the next. You can kind of see how this is working. It's almost like what's that thing in like cross country where you hand off the baton? Yeah, what do you call that run? Like doubles or something? No, not doubles. Yeah, the relay. Yeah, it's kind of like a relay, right? It's like you're finding one function and then you're giving that value to the next function, right? Okay, so let's try the next one. So this is going to be almost the same, except we're switching it around. So remember that this is a non-commutative action, so we can expect to get a different number. Now, there may be some situations where we get the same number by chance, but in general, we can expect a different number. So here we're looking for F composed with G at 0, and that's going to be, well, F of G of 0. So let's find out what's happening at 0 on the graph of G. So at 0, well, if we look on the x-axis, here's 0. Looks like it crosses the y-axis at 1. So G of 0 is equal to 1. Okay, so G of 0 is equal to 1. So that means that we are looking for F at 1. Now we go to the graph of F and see what we get. Okay, so here's our graph of F. And, well, we do have to be a little bit careful because it's not like each of these ticks is 1. right? We have to look at some of these labels and some of our legend here. So looks like from here to here is 2, so from halfway that's 1. So we're looking for f of 1, which is right here. So f at 1, well, it looks like it actually crosses the x-axis there, so that will give us a 0, right? So it looks like this is equal to 0. So yeah, you can see right off, here's another example of where we changed the order of the composition and we got different values, right? Okay, let's do one more. Let's do g of g at 3. So keeping in mind, you can compose a function with itself. So let's do g of, let me write it out properly. G composed with g at 3. And that, I'm just going to have to write it underneath, is equal to g of 3. Okay, so let's find g at 3. So here's 0, 1, 2, 3. Okay, so it looks like we are, okay, well, we'll have to do a little bit of mental math here. I think initially I meant to write f. Yeah, that was the, you know what, I'm going to quickly change this. I hope you're okay with that. I know it's kind of annoying to change a question, but this was supposed to be f. And you'll thank me because that would have been a nasty little question. So let's change those to f's. I hope you're not using pen if you're writing this down. So let's do f's. Let's change those all to f's, and it'll be much. Oh no, not 3. Okay, you know what? I'm gonna change it again. We're gonna do. I don't know why this was so messed up. This was supposed to be f of f at 1. So sorry to change it again, but again, it's going to be a lot more straightforward if we have some nice numbers. I'm not trying to get us to do like crazy like arithmetic gymnastics here, which is what we would have had to do if we kept the question the way it was. I just want us to get a sense of what these functions are all about. So f of f at 1. So let's go back to f. So let's figure out what f of 1 is. So f of 1 is, okay, well, I go over 1. F of 1 is equal to 0. Okay, so that means that f of 1 is equal to f of 0, because f of 1 is 0. And f of 0, going back, f of 0 is what we already figured that one out. It's negative 2. Okay, so it's negative 2. So that's equal to negative 2. Okay, so that's pretty much all there is to it. I mean, there's definitely some challenges that we may face when we're working through some of these problems, but that's the gist of composing functions. Okay, are there any questions about that? No. Okay, we're good. Okay, so I'm going to end the video there, and then we'll just do a little bit of work. Actually, before I end the video, I just wanted to show you what the homework for today is. So here's some more information on composing functions if you'd like to read that. There's a lot of information on it and a few more examples if you like that sort of thing. So what we're going to do is I'm going to get you to work on this set. I'm going to put it on Google Classroom in a moment. I'm going to get you to do the first half of these and the first half of these. And finally, I'm going to get you to do the first half of these. Okay, so tomorrow what we'll be working on is thinking about the domain and the range and how that is going to affect the composition of functions. So we're not quite there yet. I don't want to do too much in one day, but I'd like you to try these out. This is going to be the 1.3 exercise set. Let me draw that a little bit nicer. Yeah, I'll do a highlighter. How about? There we go. Oh, that's much better. Okay, there we go. And this too, and then this one. Okay. Okay, so I'll post that on Classroom in a moment, and we'll spend the rest of the class just finishing up some of that. Okay.